says, what is the exact solution or solution? What is the exact solution or solutions for A and B? Huh? Are you giving the exact solution right now? Okay, what do you think the exact solution is? I can't hear you. 24 divided by 14. 24 divided by 14, is that the exact solution? What does the calculator do after a bunch of decimals? What does the calculator do? It rounds it. And if you tell me, oh, it's like 1.7, is that the exact answer? It is not. When I ask for an exact answer, I want the exact answer, not an approximation. So if you type it in the calculator and round, then you are not giving me the exact answer. Okay? So how do we get the exact answer if when I type it in, it's a horrible decimal? It's going to be a fraction. So 24 divided by 14, does that reduce or is that it? What can we divide the top and the bottom by? Okay, so that's how we reduce. We do the same thing on the top and the bottom, so we're not changing the value, we're just changing the number. 12/7 would be the exact solution. The exact solution. Okay? So there are times where we're going to want the exact solution. There are times where we're going to want an approximation. So we'll do both today. The second question, B is x squared equals 5. How do we solve that? Okay, but if I square root, plus or minus, and what is square root of 5? Is that the exact solution? No, square root of 5 is an irrational number, so the decimal is going to go on forever, and there's like no pattern, there's no repetition, it's just a decimal forever. So if you type it in your calculator, you're not going to have the exact answer. What is the exact answer? That. And there's more than one answer, so I'll put it in squiggly brackets. All right. Okay. Now before we start example A, or example 1A, write small. Or if that is not possible, get yourself a supplemental piece of paper because there's going to be a lot of work. Well, you know, some people didn't know ahead of time, so they started writing right in the middle, and you know how to. Maybe you don't have to write that small, but like, there's going to be a lot in that space. So keep that in mind as you start. Maybe start in the top corner and work way over. Okay. I'm just warning you ahead of time so that you have enough room. So we're going to solve the system of equations. This is review. Solving the system of equations. We've already done this kind. You can do it by substitution or elimination. And when we look at these, would you think the way it's set up right now, it might be easier to do substitution or elimination? Okay, so if we do elimination, then we have to completely eliminate one of the variables. If I add them up, will we completely eliminate one of the variables? Yeah. Okay, good. Then I can use elimination. So we get 2, nope, just kidding, can't add. 3x squared minus 3x equals 2. So we completely eliminated the y's. So now we can solve for x. How do we solve for x when you have an x squared and an x squared? Not yet. Set it equal to 0. That's first step. Set it equal to 0. So move that 2 over. Now, so when you said take out the greatest common factor, were you trying to factor it? Okay. So is there a greatest common factor? So if there's not a greatest common factor, what do we need to do to factor this time? Guess and check? All right, go ahead. Okay, so if you try to factor it and it doesn't factor, maybe it's not factorable. So what is the backup plan for solving an equation that's not factorable? Yeah, who knows the song? You know the song. You don't know the song? Quadratic formula? I'll sing it.
You gotta warm up. You gotta warm up.
Nah, I warmed up.
Oh, I do know that song.
It's to, oh, you're singing it?
That's what I think.
So it's to the Pop Goes Weasel. All right. So it's the quadratic formula. Just writing it down. Quadratic formula. There is another way besides quadratic formula. You can also solve by completing the square, but we're not going to do that till the end of the year. Okay. Just go over quadratic formula now, right? It is x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Can I do it again? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Guess who's not going to tell you the quadratic formula ever again? Just kidding, I might do it again, but guess who's not going to feed you the information if you don't memorize it? Guess who's not going to feed it to you if you don't memorize it? Yeah.
Jesus?
Jesus will not feed it to you. No, Jesus would feed it. Alright, let's do the quadratic formula. So remember, this is in the form of ax squared plus bx plus c, so you can get your a, b, and your c from the coefficients, as long as it's in the correct order. So we have x equals opposite b plus or minus square root b squared is negative 3 squared, 9, minus 4 times 3 times negative 2, all over 2 times 3. All right, and then we gotta simplify. So 3 plus or minus square root 33 all over 6. That wasn't so bad, was it? What are we trying to do though? What am I trying to? What was it? What are we doing here? We're solving for x. Is that what the directions say? Oh, once you find x, then we gotta plug x in and solve for y. Are you ready?
No.
This is the part that takes up the space.
I was gonna say like, it doesn't take up that much space.
No, that didn't. So that is x, but actually how many x's are saying right here? 2. So we will be plugging in 2 x's, but I promise, after you plug in the first one, plugging the second one won't be as bad, because they are like the same numbers, just one's plus and one's minus. So we're going to plug them in. And we're getting the exact answer. That means I'm not going to have a decimal line I'm done. It's all going to be radicals. It's a good exercise on do we know how to do arithmetic and like higher level arithmetic, I should say. Okay, when I look at my 2 equations, here, which one do you think we should plug it into? I agree, but before we start, no, we'll just plug it in. Let's just start it. Okay, let's plug it in for the second one. So the second equation, wherever we see an x, we're going to plug in that. So I will have 3, and I'm just using the plus this time. You can get through this, you can get through anything. So what did I say about what?
So you say.
Oh, so I say. Well, I've already done it once today. I'm feeling tired. I can get through anything now. So does everybody know what we just did? We plugged in x into the second equation. We just solved for y, but it's easy. Y is by itself. So all we have to do is kind of add this stuff together and then move it to the other side of the equation. So we'll work on adding that stuff together. So order of operations, you do what's inside the parentheses first, but there's nothing to do inside the parentheses. So after parentheses, what do we do for order of operations? So is there an exponent we should do?
Yeah.
So this says square that. Now when you have division, you can square the top and the bottom separately. That is something you are allowed to do. So I am allowed to square this and square that separately. I am allowed to do that. That's the quotient property of exponents. Power of the quotient, that's what it's called. Yeah. Anyway, so I can square the bottom and get 36, but how do I square the top? Part of it does. How do we square the top? Joey said it. Yeah, you're going to have to write it twice in Tori. Oh, come on, it's fun. Okay, so we do 3 plus radical 33 times 3 plus radical 33. And we're going to FOIL. And then the more that you FOIL perfect squares like this, the more you FOIL perfect squares, and maybe if you were in honors last year, you learned a trick to help you go faster. I know the trick, so I can do it really fast. We'll talk about the trick eventually, but the more you practice it, you should develop this trick that helps you go faster. Anyway, so 3 times 3 is 9. And then we multiply 3 times radical 33, but they're different things, so you're going to just put them together. 3 radical 33. Then the inside, 3 radical 33. And then the last term is square root of 33 times square root of 33. So that's where they cancel out, that last term. Only. Okay, and then we are going to combine our like terms. So 9 and 33 gives us 42. What is 42? 42 plus 6 radical 33. So that's our numerator. What's our denominator? What is 6 squared? 36. Okay. All right, so now we'll bring down that plus sign. And what do I have to do here? I distribute the 2, but what's 2 over 1? So we are only distributing the 2 to the top numbers. So we get 6 plus 2 radical 33 over 6 plus y equals 0. Yes. Oh yeah, we totally could. What's my next step going to be though? Yeah. So I totally could. And in fact, in the last class, that's what we did, but then I had to go back in anyway. So what's my next step going to be? You need to go to the office. You can't just go out to your car. So go to the office and then you have to like tell them what you're doing.
Yeah, I know.
Okay. Well, I just want to make sure. All right. What do we have to do next? We have to combine these like terms. And to combine the like terms, we have to have a common denominator. So that's our like term at this moment. We have to have a common denominator. That one, what do I have to do? Times by 6 over, I'm going to multiply the whole thing by 6 over what? I have to do 6 over 6 because I'm really multiplying by a value of 1. It doesn't change the value, it just changes the appearance. All right, so now we have 42 plus 6 square root 30, 33, plus 36 plus 12 square root 33. And then we add them together, so all over 36.
Why do you do the 6 over 6 again?
Because in order to add these fractions together, they have to have a common denominator. So we made this one 36. Whoops, sorry, went too far. All right, so now on the top of in the numerator, I can combine like terms. 42 plus 36 is 78. Plus, and then our 6 radical 33, our 12 radical 33 is 18 radical 33 over 36 plus y equals 0. We're so close. We're almost there. It'll be so satisfying when you're done and you get it.
Every new thing you learn just gets longer.
Longer and longer. I promise, after chapter 7, we're going to do a teeny itty bit of chapter 8, and it'll be super short. You're going to be like, this is the easiest thing ever. And you just did the hardest stuff ever. And then after that, we're going to go and do trig. And trig's going to seem really easy compared to this.
Why are you saying chapter 8?
Well, partially to get it over with, partially make sure everybody who's in this class should be in this class, because you aren't going to be able to do chapter 7. I don't want to find out second semester. And then also, because I want to make sure we do matrices before everybody's taking their ACTs. And matrices are chapter 8, and they go out in chapter 7. Matrices are easy. But they are. But we don't do a lot of them. It's introductory level enough so you can do your ACT. That's all. Okay, but going back to the most lovely, longest question ever. Do you remember how to reduce these? How to cancel stuff out? Do you remember how to do it? Can I just cancel the 18 and 36? No, don't do that because the bunny will die. So what? In order to what? In order to reduce these, I have to factor out something that goes into 78 and 18, and that also goes into 36. I basically have to divide the entire top by a number. I have to like undistribute. What number goes into 78 and 18, and it will also cancel with 36? 6. Ooh, you guys are on top of it. So we'll factor out that 6, and I'll have left over 13 plus 3 radical 33. And then on the bottom, I'll factor out that 6, and I'll have 6 left over. So I can cancel those. And we still have plus y equals. So now let's solve for y. How do I solve for y? Subtract what?
Subtract
that.
fraction.
Okay, so if I'm going to subtract that, that is the same thing as like multiplying by -1. If I'm subtracting it, it's going to be the same thing as multiplying by -1. Because that's how I get it to the other side, right? I just don't want to write it over there. Is that okay?
Yes.
So I'm going to multiply by -1. It's going to be the opposite on that side. So when I multiply by -1, what is -1 over? It's over 1. So I'm only multiplying the top part by negative. Oh, we only did the positive version. We haven't even looked at the negative version yet.
Do we get to do that too? How do we want to do that?
I don't have enough room for that.
Did I? Oh, you weren't here when I said you're gonna.
Right small.
Right.
No,
Well, don't worry. Hey, listen. When we do the negative, because all we're changing is a negative sign, we're not going to have to go through all the steps again. We aren't going to have to. So you really actually won't need that much more room.
I thought we already canceled the
We canceled one of them. Remember the denominator is 36? So I factored in root 6 times 6.
Oh, okay.
So I canceled out the 6, but I was visually trying to show how I'm canceling it by factoring it. Okay, so this is the y. So our ordered pair, our first ordered pair, what was our x? I don't remember. Somewhere way up there. 3 plus radical 33 over 6. And then our y value is negative 13 minus 3 radical 33 over 6. There we go. There's our first order pair. I'm okay if you don't want to check that. It's just gambling a little bit this year, right?
No.
You need to relax.
Actually, yes.
Okay, so now to do the second ordered pair, let's just kind of go back through our work and make it a minus sign and see how much that actually changes. So if you have a second color, I'm just going to change the color because I don't want to have to rewrite everything. So if you have a second color, I'm going to go back through it and just change that, how we had a plus minus. I'm going to do the minus part now. Okay, so now instead of right here where I squared the 3 plus, I'm now squaring the 3 minus. So this one is also a minus. You can't tell the difference between those. I need a better color. How about, no, that bright green? Does this show up? Does that show up?
Yeah.
Okay, so now I'm doing minus signs. So what does that change when I foil? That changes these. Can't change. I use all the colors that I don't want to use. And then when I add all those together, that, oh no. Oh no. I know, I don't have to fix that. Just leave it back. Changing these, changing that. It only ends up changing those two, so it only ends up changing that one. So I'm doing it black this time. Over here, it changes this one to a minus also. So this one's a minus. Over here, this one is now a minus. Are you following? Am I going too fast, or are you following? And then when I add my negative 6 and my negative 12, it's now a negative 18. And then when I factor out that 6, it's still a minus right here. And then when I move the stuff to the other side, well, it just becomes a plus. So my other answer, that was the only difference. So my second one now is 3 minus radical 33 over 6, comma, negative 13 plus 3 radical 33 over 6. Unless I made a mistake somewhere, which is always possible. This is just more about remembering quadratic formula. This is more about remembering our radical rules and our simplifying rules. Adding fraction rules. That's what we're doing today, is just kind of reviewing that stuff. Yeah.
Do you mind going back up to make sure that I put the minus is
Oh, everywhere.
because I was waiting to like do work and then I can show that instead of switching them onto it.
I didn't go all the way up, but I went.
That's cool.
And then we have lunch.
Okay. Plug your phone away.
I forgot.
Can't you just ask for lunch? Okay. B. We're gonna look at B now. We're gonna look at B now. Are you done looking at this one?
Yeah.
The black one at the bottom. You can see they're almost exactly the same. So we had to do the word once. All right. Are we ready to try B?
Yeah.
Sure.
I'm so confused on last night.
Yeah?
Yeah.
When you look at B, would you do this by elimination or by substitution? Because it already says y equals, so we're going to substitute what y equals of the bottom one into the top one. So we'll do 4x squared minus 2x minus parentheses 5 minus 4x minus x squared close parenthesis equals negative 1. So we use substitution. No, because where's the step right before that? Here? No, before that. When you go to move it to the other side, we'll multiply by negative 1 to get it over there. That was still. No, because regardless, you still have to move it to the other side so that positive 13, regardless, is going to become negative. When I move this one over, it'll change the sign. And that one's going to All right, and then we're going to distribute that negative sign. So we have 4x squared minus 2x minus 5 plus 4x plus x squared equals negative 1. Whew. Combined like terms. 5x squared plus 2x minus 5 equals negative 1. Okay. What should we do? Make it equal to 0. Yes. Add that 1. You got to do that before you do any more solving. 5x squared plus 2x minus 4 equals 0. Now what should we do? Factor it? Did you already try? You're funny. It's like I taught enough students and everybody's my favorite. I'm a desire.
I feel like my
What do you think?
No, like really.
Alright, yeah, this one doesn't factor, but even if it did factor, if you didn't want to take the time to factor it, and you did quadratic formula would work out to be nice, easy answers. If it is factorable, if you did quadratic formula, you wouldn't get radical answers. So quadratic formula always works. Always, always, always works, regardless if it's factorable or not. This one is not factorable, so we will do quadratic formula. Let's finish one. Do you think?
I don't know.
Well, I sang it twice.
I said that.
Okay. So we do x equals opposite b plus or minus square root b squared minus 4ac all over 2a.
Is that a negative 1 divided by 5?
It is a negative 4.
Okay.
That's fine. My handwriting hasn't always been the best. I'm going to simplify it. I'm going to get 84 underneath, and on the bottom I'll get 10. Does radical 84 have a perfect square that can be factored out of it? Remember simplifying radicals? You make like a factor tree, and you pull out any perfect squares that go into 84. What goes into 84? 4 and 21. And what is the perfect, or the square root? 2 square root 21. So I'm going to replace that. I know, I don't know why it does that sometimes. I don't know if I need to charge this. I don't know.
It's just fun.
It's annoying. All right, and I'm looking at this and I'm seeing all these 2's. You think maybe we could simplify before we plug it back in? Well, does anything factor out of the top that would also cancel from the bottom? If I factor out that 2, and I factor out the 2 here, then I can cancel them out. So my next step is going to be x equals negative 1 plus or minus square root 21 over 5. So we just factored out the 2 from the top, canceled it with the 2 from the bottom. What?
You don't do it like you did on the top where you put the 6 on the outside? Like, you know where you put the 6 on the parentheses and then did it? You don't do that?
You talking about from the first question?
Yeah, like how
What
do
are
you
you talking
factor
about?
when you factored out the 6?
Oh, yeah, I was doing that in my head.
Oh,
I'll rewrite it. I'll just rewrite it. I got space. I did it last time. I like wrote it all the way out so that everybody knew what I was doing, and then I won't always write it like that. But I can. So I used like greatest common factor, kind of GCF factoring here, and at the bottom 2 times 5. And if you factor them out, you can cancel them. So I have x is equal to -1 plus or minus radical 21 over 5. So we have x. What do we do to get y? Which equation would you plug in?
The second one.
I think I do the second one also. 5 minus 4x minus x squared. That one's already solved for y. 5 minus 4x minus x squared. Before I go through the whole process where I'm going to multiply that out and combine my terms, eventually I am going to have to add together these 2 fractions. I'm going to have to add those together eventually. What will my common denominator be eventually? Can you look ahead and see? It is going to be 25. Why? Because we're going to square that 5, right? We're going to square this top. And we're going to square that bottom, so that one will end up being 25. So I am going to eventually have to make this one 25. I'm going to have to multiply this one by 5 over 5. Well, I'm multiplying everything. I'm going to do that too. Are you dying yet? Okay, so I'm going to multiply this out. This is going to be -20 times that stuff. So I'll have plus 20 minus 20 radical 21 over 25 minus something over 25. So I'm going to FOIL that, and the sooner you learn the trick about foiling, it's going to help you a lot. When you FOIL, the first is always the first terms multiplied together. So if I'm doing -1, what's the other first term? -1, what's -1 times -1? -1 times -1 is? 1. Okay, and then my last term is the last one multiplied by itself. So that one would be 21. My middle term is my outer and my inner. But my outer is going to be -1 times radical 21, and my inner is going to be -1 times radical 21. Which are these 2 terms right here. So if I multiply those together, they're going to occur twice. This only works for squared terms, by the way. If I multiply these together, what's my middle term going to be? -1 radical 21 and another -1 radical 21. What will my middle term be? It's going to be -2 radical 21. Like you're adding the 2 of them together. If you're not ready for that trick, then just write it all out and FOIL it. Not everybody's ready at the same time for shortcuts like that. And then what's that negative say? It's going to distribute and change all the top signs, because that's -1 over +1. It's only going to change the top signs. Oh my gosh. Tell me how you really feel. Not you. Okay. So I distributed that negative sign. I kind of combined my like terms as I did it. I put it all under the common denominator as I did it, which I had prepared for. And then I have y equals, and I have a 5. Oh my gosh, am I going to have to add that in there too? What common denominator do I need on the 5? So I have to multiply the top and bottom up by 25.
Wait, how did you get the,
Huh?
how did you get the, where did you put the, on the top one you put, on the first 1/1 in the below, what did that mean? Why did you do that?
Because it was a minus sign, so I distributed the negative 1 in. That's when you were talking about the ghosting house,
Oh.
when I was doing that. So now I'm going to combine all my like terms. I'm going to get 123 minus 18 radical 21 over 25. For y. What, did I make a mistake? Well, this is 125.
Plus 20.
Plus 20
Minus
minus 22. I just did it fast because you guys were talking about other stuff, so I felt like I could go faster. Yeah.
I got negative 2 radical 21 plus 22.
You got one?
You had to multiply that with 1. Yes.
How did you get the minus 22 plus 2 radical 21 on the second one?
That's really.
Because it has to be.
It was, but then
So.
I didn't add the 1 and the 21, right? But there's 22, right? But then outside of it, there's a minus sign.
Yeah.
So then I distributed the minus sign. That's how I switched my sign. And we're not going to go through and find the negative one because it's kind of. That's just the positive one. That's just the positive.
So you did the 25 over 25.
Yeah.
Why is that again?
The red one?
Yeah.
Because I have to add 5 with this fraction also. I have to have common denominator to add things together, right? So I had to make 5 over 1 into 125 over 25. But I just kept it right here. I didn't want to keep writing new steps every time. Yeah. I don't know. I'd have to go through and see. But you know, you just go through and change all your signs and just see if that works out. I don't know if it would because of that 5. It might be a slightly different number, but it would work out pretty well all the way to probably about there.
Why would at the bottom be 50? 25 plus 25.
Because when you add like terms, you don't change the terms.
Oh.
You keep it common. Yep. Okay. I know it's a lot, but the reason why it's so much is because you don't know those fraction rules by heart. You know, and you haven't foiled in a while, and it's been a while since you've seen this stuff. But that will be like the most challenging thing, and I didn't give you like 8 of those at all.
4.
No.
2.
Like 6. I think there's 2, but one of them's like really easy to put
Wait,
back in.
are we talking about a test or something? Oh. So we're just doing 2 times.
We have 10 minutes still. I'm gonna start on the back with graphing calculator stuff. The back is just graphing calculator stuff. Okay. So on the back is says find the approximate solution. So we don't need the exact. And it does say to use your intersection tool on your graphing calculator. I don't know that everybody had the same graphing calculator experience last year, so I'm going to teach it. But if you already know how to do it, of course you can work ahead. It does say to round to the nearest hundredth when necessary. So if we have to round, it'll be to how many places? 2. All right, here. Take this. Grab yours.
Yeah.
Okay, so we're going to go to our y equals. I have a calculator that you can kind of watch me do also if you need to see what I'm doing. But we're going to go to y equals on the calculator, and you're going to type in your 2 equations. And then when we do graphing calculator stuff, if I am ahead of you and you have like an error or yours doesn't look the same, if you keep it a secret from me, I'm not going to know, and I'm not going to be able to help you if you don't say, hold on, I have an error. And I don't want to find out 10 minutes later you had an error 10 minutes ago. I want to know right away if you have an error so I can fix it right away so everybody stays together. Okay? But if you know how to grab this stuff, you can work ahead. If you already know how to use the intersection tool, you can work ahead. I'm going to show anybody else who doesn't know how to use it how wonderful it is. Oops. I have to fix my window. Once I hit graph, we might have our windows separate, set up differently. If you ever want to fix your window and make it that nice -10 to +10 window, you hit zoom 6, hit zoom 6, hit zoom 6, and yours should look like mine. So if anybody has problems, let me know right now. Who has problems besides you? Besides you don't have problems. Who else has problems?
Yeah, I'm not seeing this.
You are more than welcome to try it on Desmos, so you're not just sitting here. You can, on like your phone, go to Desmos, D-E-S-M-O-S. Are you listening, Hayden? I'm talking to you. Go. On your phone, go to DESMOS.com for Desmos. It's not going to be the same, and you cannot use Desmos on a quiz or a test, but you can at least see the pictures and kind of follow along, but bring your calculator after lunch and make sure you know how to do it. Okay, does everybody have this and it looks the same and nobody has errors? So on Desmos, you can just type in the whole equation exactly how it looks, pretty user friendly. And once you type it in, it automatically graphs it for you. Okay, if you have questions about that, let me know. All right, we're going to find the intersection. So finding the intersection, your calculator will, there's 3 of them, but your calculator only does 1 at a time. So you're going to have to do this procedure 3 times. All right? So the first thing you're going to do is you're going to go to second graph. Nope, I lied. Second trace. Sorry, wrong one. Second trace, which is the calculate button. And it looks like that. And then we're finding the intersect tool. The intersection tool, intersect. So you can just type 5. You don't have to hit the arrow down 4 times. You can just hit 5. Go straight there. And it will ask you first curve. So it automatically goes on to whatever the first equation is that you typed in. And you see how it's sitting on my blue one? And that is my first one that I want to find the intersection between. So I'll hit enter. And then it says second curve. And you can't see where it is because at the bottom it's telling me it's sitting at 0, -16, so it's not on my picture right now. Do not use up or down arrows. Use left or right. I'm going to go to the left. And you can see the numbers changing at the bottom, and then eventually my little cursor shows up. So it is now sitting on the second curve, and that is the other one that I want to find the intersection between, so I'm going to hit enter. Who's talking to me?
I don't understand how you have the second one to come up.
Just hit your left arrow. It should automatically come up. Oh, you didn't hit enter. You didn't hit, after the first curve, you have to hit enter. Now it's on the second curve. Okay, after you hit first curve, second curve, do you see how it says guess?
Yeah.
You have to tell your calculator which of the 3 it's going to find. I always like to go left to right so I don't miss any. So I'm going to go all the way to the left and use my arrow until I'm close to where those 2 cross on the left. So I'm going to go close to it. And if you don't do this next step, you're going to not have the right answer. You have to hit enter. Last bell. I don't have the right answer. I'm like, you just hit enter. At the bottom, if you hit enter, it says intersection. So you know you've hit enter, and it told you this is where it crosses. Gosh, that's a lot less work than the way we were doing it. Okay, so we're going to round that ordered pair to how many decimals? 2. So negative 3.52 and 4.04. Ordered pair, write it down. And we have how many more to find? So if you feel like, okay, I got this, then you can work ahead of me. But I'm going to go through the process again. But this time I have to find the second intersection. So you have to do all the same stuff again. Second trace. And then you go intersect, 5. And I have to make sure that I'm on my first curve, which automatically goes to the first one. Enter. Second curve, and I'm automatically on the second curve. Enter. But the guess, we have to tell the calculator which one you want. So go close to it, and then do what? Enter. So you should get negative 2.18 and 1.36. Yes. And then you get negative 2.18, 1.36. And then one more. Same thing again. Second trace. Intersect. First curve. Yep. Second curve. Yep. And then put it close to where you were guessing. And hit enter. So it says intersection. And then with my rounding, when I go to round that 9, it has to round to a 10, so it's actually 1.70 and negative 6.39. 1.70. Negative, I already forgot. What is it? 6.39. Okay? So when we get back from lunch, we have 2 more to graph, and we also have that other assignment to grade when we get back from lunch. See you in a bit. Okay, so we left off here. We're going to graph these on the graphing calculator. So the first equation, do you know what it will look like? It will look like a circle. Good. How do you plug in x squared plus y squared equals 12 on a graphing calculator? You have to solve it for y. You have to solve it for y to plug that in our graphing calculator. So, to solve this equation for y, what are we going to do first? Minus what? Subtract the x squared, so we'll have y squared equals 12 minus x squared. And then to solve for y, what am I going to do next? Square root. But if I square root, what also do I have to do? When I square root? Plus or minus, right. Plus or minus square root 12 minus x squared. So now we have solved for y.
Does that not cancel the x squared?
It does not. It does not because you would have to do 12 minus x squared first before doing the square root. So you can't square root just part of it. You'd have to square root the whole quantity after you subtract. There's like understood parentheses right here that say you have to do this first. So you can't. But it doesn't matter. We can just type that in our calculator with the exception of there's no plus minus for your calculator. There's no plus minus. So what you have to do to type this one in your calculator is you're going to have to type like y1, that first equation, as square root of 12 minus x squared. And then y2, we will type in negative 12, square root of 12 minus x squared. So you have to type in both parts separately. So go ahead and type that in your calculator. And then once you've typed it in, you can hit graph and I'll catch up to you. Well, it's not going to look like it yet. Do you know why? Because it's a rectangle, right? Not a square. So if you graphed it correctly, it should look something like mine. Depending on which kind of calculator you have, it may look more connected or less connected. It should be connected. It should be. Yeah.
What do I press to like get the window set?
Zoom 6. Zoom 6. I am going to change the window just so you guys can see it looks more like a circle. Because this right now looks like squished. And that's because our screen is a rectangle and we go from -10 to +10 on horizontally and vertically, but they're different sizes. So if you go to window, if everybody goes to window, and let's change our Y minimum to be -6 and our Y maximum to be +6. Go to your window and change that, and then hit graph again. It'll make it look more like a circle.
What are we putting in our Y equals right now?
Because you were.
Yeah.
Can you show him those?
Wait, no, window.
-6. Yeah, I don't. So you can type in Y1. Okay, so you can kind of see it's a circle, kind of. Some of you, I think the older calculators probably look more like a circle than mine. A little bit more. Okay, so now we're going to do the other equation because we have to find where they cross. So let's go type in the other equation. We look at it, and does that one say Y equals? Okay, so we got to solve that one for Y. What do I do first to get Y by itself? Square root it, square root. But if I square root, what also do I have to do? So I square root the squared, and I can do the whole thing because it's all squared. So I just go Y plus 1. And then subtract 1. And I'm going to write it in front so everybody can see that it's not part of the radical. You don't have to write it in front, but that's why I wrote the -1 in front. So since there's both a plus and a minus, we are going to have to type in two separate equations. So I'll make my Y3 -1 plus radical x, and then my Y4 -1 minus radical x. So we'll go ahead and type those in. And then once you have that, hit graph. And yes, if you have the color ones, you now have 4 colors.
No, mine's not colored. That's
I know, I said if you have
That's
the
so
colors.
sad.
That's okay, it still does the same stuff. So now we have to find where the graphs intersect. Even though we typed in 4 graphs, there's really only 2. Your calculator just won't type in 2. So we're going to do intersect. Remember that second trace. Intersect is 5. And it says first curve. So right now it's on the top half of the circle. I want to find this top intersection first. So I'm on the correct part. I'm going to hit enter. And then it says second curve. Am I on the second part that I want to find the intersection with? No. So to get there, your calculator goes in order that you typed them in. If you hit the down arrow, you can look up here and you'll see which part it's on, and you'll see the little cursor changing. So hitting that down arrow, I'm able to get on that curve I want to be on. So the left and right go side to side on that curve, but the down or up will change which part it's on, which equation it's on. So once I'm on the second curve, I'll hit enter, and then I need to go close to where they cross so the calculator knows what I'm looking for, and then hit enter. so that we find the intersection. So if you get that intersection right into 2 decimal places, try the second one on your own. Where did you type? You gotta start over. Second trace. I was asking you which one you were on. Okay, enter. And then right now you're on down there. We want to go to the down there. See how it switched to that right now? Because it goes from Y1 to Y2 to Y3, and that's where we want to be. So hit enter now. And then go close to where they cross. And that's good. Then hit enter. All right, so I'll do it real fast. You can check to see that you got the same answer as me. So you should get for the second one 2.36 and then negative 2.54. All right, there's one last example, and the reason why I gave the last example is just I wanted to go over how you can type in fractions easily on your calculators. Some of you have this capability. If you have the much older calculators, you probably don't have it, but I'll show you how to do it either way. So go to y equals, clear out what you have, and I'm going to show you how to type it in as a fraction. What are you trying to do? This one down here? Okay, so you have to hit enter. Now hit your down arrow, show your own down. Oh, there. Okay. Yeah. We didn't guess it. Because I think you have the same. You have the same. So right here. Enter. Oh wait, that's not the one. Oh, great. Enter. And then must have did over before. There you go. You were like this way and it wasn't showing up on the graph. Do you need help on this one or on the next one? Okay. I'll help you a little bit. Let me just show you how to type in a fraction. So I go to y equals, and if you have the newer software, I'm not saying it has to be the color calculator, it's just the newer software. When you do the alpha button, you hit the alpha button and then you hit y equals, this menu will pop up. So if you hit alpha y equals and it didn't pop up, you can't do what I'm about to do. So if you hit alpha y equals and it popped up, hit enter, and you should see it is ready to plug in fractions.
What's alpha y?
There's an alpha button, and then the y equals button. So this also works in the calculation screen. If you ever want a fraction thing to type in, you do alpha y equals. Yeah, alpha, and then y equals. We don't have it.
Oh.
Okay, so if you don't have it, I will type my second equation in if you don't have the fraction thing. If you do have it, you should be able to type in your equation with fractions. I'll be right there. So if you don't have it, then you're just going to have to type in fractions in parentheses. So I'll have to do -4 divided by 5, close parenthesis x, plus parenthesis 23 divided by 5, close parenthesis. If you don't have fractions, that's how you'd have to type it in. And then if you do have the fractions, you can just do like 3/7x plus alpha y equals 15/7. And then go ahead and find your intersection once you have it. So you probably don't have the software. So, I know, I don't know why, I haven't seen anybody who had this issue.
Just kidding.
But this is one of the older calculators, so it must not be the most updated calculator. There is a way to update it, I don't know. The TI 8 or pluses, I believe, can be updated.
That's why.
But it's okay, you just have to use purposes instead. Did you find the answer? Why don't you do this on business? Business? Were you out of the room when we talked about it before? You don't have to grab and calculate?
I don't know what that is.
It's a website. DESMOS. Try it. Go to it. DESMOS. It is.
I didn't know.
Yeah, and this is a nice easy answer. Did you get a nice easy answer? Okay. Okay, well, if you have that, take out your homework. I'll pass out your assignment for today. Sorry. I'll pass out your assignment today in just a moment, but we still have that other assignment to grade. Different, yeah. Mhm. Can you type in an equation? Yes, on the graphing calculator. On the internet, on Desmos, you can type in anything real fast, but if you like to, on the graphing calculator. It's really good.
I've never done it, but I would.
I've never seen that.
I've seen girls.
I'm guessing maybe you're right.
I've just never seen a guy who's like flying.